Hi, today I'll be guiding you through an FRQ from 2010, problem number 4. In this problem, let R be the region in the first quadrant bounded by the graph y equals 2 root x, the horizontal line y equals 6, and the y-axis. First, they ask us to find the area of R. Consider the region R lying between the two curves y equals 6 and y equals 2 root x, and between the vertical lines x equals 0 and x equals 9, where both of these functions are continuous, and this function y equals 6 is always greater or equal to y equals 2 root x for all x from 0 to 9. With this information, we can set up an integral. So from 0 to 9, we can have the area under the function y equals 6 subtracted by the integral from 0 to 9 of the function 2 root x, subtracting the area under this curve. From that, you would have the area of R. When doing this problem, be sure not to look quickly over the function y equals 2 root x and overlook that it has another boundary line of y equals 6. If you would overlook this, you would have done the integral from 0 to 9 of 2 root x dx, which would represent the region under, not the region between the two lines. For the next problem, it wants us to find the expression of the volume of the solid obtained by rotating this region R about the line y equals 7. When you revolve it around in horizontal line, you will create a washer. Let's demonstrate it over here. When you draw a cross-section of one of the washers that are infinitely from 0 to 9, you would have, with this axis of y equals 7, the outer radius would be equal to 7 subtracted by the outer function, which is 2 root x, and the inner radius would be 7 subtracted by the one closest to the axis, which is 6. With this, let's now find the area of one of these washers. As I drew out for you already, with this washer, the outer radius and the inner radius, which you subtract from. So then the area would be the area of the circle subtracted by the area of the hole with this radius. So as shown here, if you have an infinite number of washers going from 0 to 9, you will be able to write the expression v equals pi, the integral from 0 to 9 of the area. And so then, let's go to the third and final problem. It tells us that region R is a base. So from 0 to 6, the cross sections are perpendicular to the y-axis, going this way and coming right up, with rectangles infinitely going from 0 to 6, with the height 3 times the length of its base. So then write the expression that gives the volume of the solid. First, let's find the area of each of the rectangles. So then we have S, and we'll set up S as the base, multiplied by the length, which is 3 times the base. What is S in terms of this problem? You know, since they're all vertically going this way from 0 to 6, and since the original function was y equals 2 root x, you have to take into account that since it has to be xy's, you would flip that to x equals y squared over 4, subtracted by this axis, which is x equals 0. Therefore, S would equal y squared minus 4. Now that you have what S equals and the general formula of each of the rectangles, you can now plug S in, which is 3S squared. Since we have infinite numbers of rectangles going across from 0 to 6, we can write this out in an integral. To 6 of 3y squared over 4 to dy. And there. Overall, I think that these type of questions are one of the easiest FRQs to tackle. I think that area problems are very straightforward as long as you pay attention to the boundaries and the vertical boundaries. And for revolutions, as long as you draw out the discs or you draw out the washers and figure out the radiuses or the inner radiuses, I think they are very straightforward. And for revolutions, make sure to look carefully what axis it's going to rotate itself on. And lastly, for cross sections, take out one of the infinite numbers of cross sections throughout an interval and figure out what the area for one of them would be, using S as the base of it. Out of all the resources, I feel that the Barron's book for AP Calculus was really good for me. It gives you multiple problems of revolutions, examples, and also later it gives you tons of practice problems on the area between curves, parabolas. It gives you problems on volume. If you look in our calculus textbook of the 6th edition, you will also be able to find great examples of problems in chapter 6. It gives you explanations of areas between the curve, multiple examples, and it gives you tons of problems for you to practice on. And between each sections, it explains volumes. Out of these 3 type of questions, cross sections was one of the hardest for me to understand at first. So I went to khanacademy.com where they had great videos of drawings and demonstrations of how cross sections work. And also I provided many links of each of these 3 types of problems for you to practice.